In order to deliver on what I've described, there's a very, very complex problem that you have to solve. And at VMTurbo, we refer to this as the intelligent workload management problem. And solving the problem results in increased quality of service, better use of your operational resources, and more efficient use of your infrastructure. Looking at the complexity of this problem, there are many issues that any software vendor would face in trying to solve it. In a virtualized data center, you may be running hundreds or thousands of workloads, and each one in its own right has a personality. So each workload consumes different resources from the underlying infrastructure, so CPU, memory, I/O, network, disk space, IOPS on the storage. We allocate resources to each guest as well. So it may have a fixed amount of virtual memory or CPU. It may be required to access certain networks and certain storage. It may have different priorities as well in terms of the, in order to meet the SLA, certain applications may be more critical than others. They may have business continuity requirements. And they also fluctuate in terms of the demand as well, depending on the business process that they support. Hourly, weekly, monthly, annually. And so we have to figure out how to accommodate all of those diverse needs of hundreds or thousands of workloads from the underlying infrastructure. Now, the underlying infrastructure is constrained in many different ways as well, which make this a very complex problem to solve. So you may have a certain capacity of infrastructure that may have different performance characteristics, that may have different tiers of performance. You can have physical configurations like clusters and data centers, and virtual configurations like virtual data centers. And ultimately, the capital budget that you've got to spend on this is a constraining factor as well, because people don't have an infinite amount of money. So we want to try and squeeze as much out of that infrastructure while sustaining the quality of service, taking into account all of those factors. And that's a very, very difficult problem to solve. To solve the very complex problem of intelligent workload management at VMTurbo, we've built a technology to actually solve this problem. It's not a problem that you can solve by coming up with 9 different scripts which look at different problems in the infrastructure. You need a very joined up way to address this problem. And so the technology that we have, we call it the economic scheduling engine, and it's basically an algorithm which is using economic principles of supply and demand in order to manage resource allocation decisions. So the way it works is that we depict IT as a marketplace of buyers and sellers. So starting at the top of the chain, we've got applications which are selling transactions to the business. They buy virtual machine resources to facilitate their work, virtual memory, CPU, storage. In turn, they buy compute and storage resources, CPU, I/O, network, disk space, IOPS, etc. And in turn, the physical resources buy space, power, and cooling from the data center. So in our marketplace of IT, we give the buyers, the consumers, budgets, and the providers of the resource generate revenue. And we price all of the resources that get traded using a virtual currency. And what sets the price of the resource is a function of utilization. So if something becomes in very high demand, it's more expensive for the consumers to purchase with their budgets. The consumers make shopping decisions, and they look around in the marketplace for the most cost-effective bundle of resources that they can get to satisfy their requirements. So if I'm a workload that requires lots of memory, I'm going to gravitate to places where the utilization of memory is cheaper, and the price obviously is lower as well. If I'm a virtual machine that needs a lot of CPU and I/O, a highly utilized physical machine for memory may be a good place to go, because I don't need a lot of that expensive commodity, and the other commodities are very cheap to buy there. So using this principle, we can drive a lot of different use cases. The one I just described was intelligently placing workloads across the server infrastructure. But we can also use this to scale up and scale down resources as well. So if I'm a provider in the marketplace, I have an ROI associated with how much revenue I generate. I need to be profitable to stay in business. So if in my marketplace I have a cluster of servers and they're underutilized, then nobody's making a profit. So somebody's going to go bankrupt. So we shut one of the servers down. The consumers contract and go to a fewer number of resources. The utilization levels increase. And the prices, the revenue that gets generated covers the cost that they have to pay for their space, power and cooling. So we can have the opposite effect of that as well. So in that marketplace, if all of the utilization is very high, everybody's making a tremendous profit, it means that there's more room in the marketplace for more providers to come in. So we make recommendations to provision more resources in order to meet the demand and bring down the utilization and prices to safer levels.